Okay, this is lesson 4.2, solving multi-step linear inequalities. So there's your two objectives. Let's get started. Okay, so we're going to solve and graph. Okay, so you're going to start by solving these the exact same way as you did equations. Alright, so first thing is, of course, change subtraction to addition. Okay, then after that we need to get rid of the 5. So we're going to take away 5 from both sides. Cancels, and we get the opposite of x is greater than negative 1. Okay? Now, we need to get the opposite of x. Okay? So we're going to divide by a negative 1 in this case. And remember, when we divide by a negative on both sides, that flips this sign. Okay, so these negatives cancel and I get x. I have to flip the sign because I've got negatives on both sides. And negative 1 divided by 1 is 1. So x is less than 1. Now it's said to solve and graph. So we're going to make a number line. Put your number, your answer in the middle, and number on both sides of it. Whoops, sorry, I should probably do that correctly, huh? Even Mr. Ayers can still mess up from time to time. Let's start that just over. So 1's here. Mr. Ayers was thinking it was negative 1. So here's 2, here's 3, here's 0, here's negative 1. Think about what kind of dot you need. Don't forget about that. If there's no equal sign underneath here, you need an open dot. And we shade toward numbers that are less than 1. Okay? Now we can check this by picking a number that's in our solution region over here. So let's pick 0 and see if it works for our equation. Well, if I plugged in 0, and I do 5 minus 0, that's 5. That's greater than 4. So my answer has to be correct because my solution region works. Okay, let's go on to another example. Okay, so here's another one. Again, we're solving these just like regular equations. So, first step, subtraction to addition. The only thing we got to keep in mind at any point in time is if we ever have to flip the inequality sign. Alright, let's get our constants to the right side. So we're going to add 4 to both sides. Oops, sorry, this should be plus negative 1. Going to add 4. Cancel. Negative 1 plus 4 is positive 3. Now I'm going to get rid of the 4x's. I get 3 over here. 2x minus 4x is negative 2x. Now I divide by negative 2. This cancels. I get x. Remember, I divided by a negative on both sides here. So I've got to flip that sign. And it's negative 3 halves, or negative 1.5. Again, we said to solve and graph. So here's my number line. Here's negative 3 halves. So that's negative 1.5. So right here I could put negative 1 and then 0. And over here I'd have negative 2 and negative 3. We need a closed dot because it's or equal to. And it's got to be shaded toward numbers that are less than negative 3 halves. Those are over here. So again, we can check this by picking a number to plug in and see if it works in the equation. Okay, let's pick negative 2 and plug it in. Well, if I take negative 2 and plug it in here, okay, 2 times negative 2 is negative 4, and negative 4 plus negative 4 is negative 8. And that should be greater than or equal to whatever this is. Well, 4 times negative 2 is negative 8 plus negative 1, and negative 8 plus negative 1 is negative 9. And sure enough, negative 8 is greater than or equal to negative 9. Alright, let's keep on keeping on. It says the area of this rectangle is greater than 36 square meters. Find the possible values of x. Okay, so let's remember here. Area equals length times width. Alright, well, my length is 9. My width is x. and that has to be greater than 36 square meters. So this one's not even a multi-step. This one should be pretty easy. We're just going to divide by 9 on both sides. Cancels and get x is greater than 4. So x has to be greater than 4 meters to have an area greater than 36 square meters. Okay, and let's go to our last example. Word problem, yay. Okay, we're going to solve this using our 5-step problem solving process. Okay, so an amusement park charges $5 for admission and $1.25 for each ride. We go to the park with $25. I want to write an inequality that represents the possible number of rides you can go on. And I want to know what's the maximum number of rides. Okay, remember, this is writing an inequality, so I don't want an equation. I want less than, greater than or equal to, or less than, equal to. So let's start by circling what we know. We know there's $5 for admission. We know it's $1.25 for each ride. We know we have $25. And we want to know the maximum number of rides. Okay? Well, let's start with our labels. We know that we have $5 for admission. That is what we're charged just to get in the park. We know that it's $1.25 per ride. We know that we have $25 to spend. Okay, we want to know the maximum number of rides we can go on, so x needs to be the number of rides. So verbal model, let's think about this. What are we actually paying for? Well, I know I have to pay for admission. I'm going to add in the cost per ride, okay? Or the amount of money I have to pay for rides. So that's going to be the cost per ride times the number of rides. That's got to equal my spending money. Sorry, not equal. I just talked about that. We're not going to do equals. It's got to be an inequality, okay? Well, I have $25 to spend, so it could equal $25, but it can't go over that, okay? So I can spend less than or equal to $20. I can spend all of that money, exactly equal to it, or I can spend under it, okay? But that's all, all right? I can't spend any more than that, so it's got to be less than or equal to. Well, let's fill in with our labels now. Our admission was $5, plus the cost of each ride was $1.25, times the number of rides was x. That's got to be less than or equal to the amount we have to spend. Okay? Now, we just need to solve our inequality here. We're going to subtract 5. And I get 1.25 times x. It's less than or equal to 20. Now I just need to divide by 1.25 on each side. And I get x is less than or equal to, and 20 divided by 1.25 is 16. Okay? It says, what's the maximum number of rides I go on? Well, this tells me I can go on 16 rides, but I can't go over that. So, 16 rides is the most that I could go on. Okay? Alright, good luck on your homework.